So hi everyone, and thanks for being here. And I'd like to say again a big thanks to David and the Data Science Festival team, Jessica and Amy for giving me the opportunity to be here. Like I remember when Data Science Festival, when we saw Data Science Festival for the first time here in London, I really wanted to give a talk one day, and today is the day. So really excited. So what I will be talking to you about is open banking and the very exciting opportunities it opens up. And I will present our work at TrueLayer in creating data science-enabled products. A bit about myself first, though. So my name is Alex Spanos, as you heard, and I'm lead data scientist at TrueLayer. And I joined around the end of 2018 when the company was about 20 people. We're now about 200. And I joined as the joint first data scientist at the time. And it was the first time in my career I joined a company so early in its journey. In terms of my background, I studied applied mathematics and statistics, and I've been working on applying data science in various forms, I would say, for a bit more than 10 years now. But I made the formal transition into data science titled role back in 2015. And incidentally, that was one of the hardest things I ever had to do. So I fully sympathize with people, trying to make that transition. I've been there, it's tricky. So anyway, so before TrueLayer, most of my data science experience was more focused on data analysis, experimentation, etc. And my tools were Jupyter Notebooks, SQL, and yes, PowerPoint. So I hadn't had many chances to see my work deployed in production, which was something and I guess many of my peers found quite frustrating. So, joining TrueLayer, it materialized that within the first couple of weeks of being there, I found myself creating Python microservices, tinkering with .NET, deploying stuff manually on Kubernetes, thinking about CI/CD for new data science services, and what have you. So that was a bit of a surprise. And having joined the product first company, having to plan what product and feature to build was also very prominent. And my CTO did warn me that he considers me as a fully blown software engineer, so I had to up my game a bit. Okay, so long story short, it's been, I think, an immensely educational journey for me, certainly enjoyable and occasionally uncomfortable, but full of interesting challenges. Cool, enough about me, and on to the talk. So I will cover a few topics today. Firstly, I will introduce open banking in condensed form, and discuss how it has become a very important catalyst for innovation in financial technology. And then I will move on to introduce my company, TrueLayer, and present the type of products we're building inspired by open banking. And then I'll move on to the portion of the talk, which I guess most of you signed up for, which is data science at TrueLayer. And we'll do a deep dive on kind of the debutante machine learning powered service that we released around banking data enrichment. Now, one point I'd like to make throughout my talk is how for many businesses, the real value of data science emerges a little bit later in their journey, right? So I hope some of the topics I cover today will be useful for people either planning to work as a first data scientist for a company, or for people at places where data science is still a bit on the edge. Cool. So let's get started. Now, open banking. Many of you have heard this term, but may not be quite sure what it means. So in a nutshell, it's a regulation. It's a series of reforms that addresses how banks deal with your financial information that is specific to the UK. Open banking is specific to the UK. But it follows a European Commission regulation called the Second Payment Services Directive, or PSD2. I hope I've not lost you yet. I won't talk about regulations anymore. But more or less, this regulation enables consumers two things, essentially to give companies secure access to bank account information for two purposes. Number one, sharing of banking data, and number two, initiation of payments. And the idea behind the regulation is to boost competition and innovation in the fintech ecosystem. So if, in a nutshell, again, like open banking is a UK implementation of PSD2 and lets apps connect directly to a customer's bank account upon consent, of course, via open APIs. And I'll explain how that can be different. Now, open banking means that traditional financial institutions no longer have a monopoly over creating financial products informed by customer data. And also card providers no longer have free reign in the payment space. So it's pretty big. Now, examples. So here I'm going to share an example of an application that uses open banking data APIs to fetch financial data of their users. So Plum is a personal finance manager, kind of a budgeting application, which helps users save. So users are typically asked to link their bank accounts. I guess you're probably familiar with this functionality. So in this screenshot here of a Plum page, of a Plum kind of view, you can see a linked Lloyd's account. You can see the balance. You can see the option to connect another account, and you can also see like an analysis of recurring spending habits based on transactions. So all these things like the balance, the transactions, they are enabled by open banking APIs. And all these things, all this stuff are happening in the background. Now, it is worth mentioning that, I'm saying open banking, but there's also a different way to get this information, an uglier way. Okay, so it's called screen scraping. And this was before open banking, the name of the game. And this was essentially robots logging into online banking pages of a user who had to share their username and password and login details with the application. And I guess, as a user, that's not so, that doesn't feel super secure. And also as a provider of these APIs, it's a nightmare to maintain because imagine, the bank changes its online banking page and then it breaks your screen scraping implementation. So you have to do it from scratch and not great. So that's where open banking APIs fix these issues for both users and providers of APIs. There's a very robust kind of API authentication process, very high security. And as an API, it's a more stable source of data in theory. But yeah, it is a more stable source of data. Cool. So this is like open banking on the data side. What about open banking on the payment side? So here's an example of using open banking to initiate payments. And I'll use free trade as an example. So you may know free trade, especially with a Coinbase IPO yesterday. Free trade is a wealth tech application that opens up the world of investing to individual consumers. And on free trade, users have an account which they top up with funds in order to invest in specific shares and other financial instruments. Now, interestingly, free trade is using open banking as the primary way for users to perform top-ups. And they use that instead of standard bank deposits or having to enter your card details, or PayPal. And with open banking, the benefit is the payment goes through instantly. It doesn't take time to settle. Directly from the user's bank account, so not through card processor networks or whatever. And the security is very high thanks to the open banking kind of implementations. And let's see how it looks like. Cool. So here a user has logged into their free trade portfolio, their application, and they say, I want to top up my account. They go into the top up page, they have a linked bank account, and they have the option to do a bank transfer from Halifax. Cool. So they choose this, they decide to top up with £1. And then here's the interesting bit, right? Instead of entering like card details and logging into PayPal or what have you, you're redirected to the mobile banking app on your phone. And the payment is authorized through the mobile banking app. And all this information is not shared with anyone. That's in the mobile banking app. Okay, some redirects back to free trade, top up complete. It says 2-4 working hours, but it's instant. Okay, so this is kind of the payments with open banking, kind of a flow. And as I use it, I guess you can see the benefit. It's nice. It leverages kind of the mobile banking apps you have on your phone already, and it's instant, which is great. It's highly secure. But also for free trade, this method of payment is much cheaper than cards. So win-wins all over the place. Of course, there's some detail to that, of course, but it's generally good. Cool. So I want to wrap up this section. Oh, sorry about that. I want to wrap up this section about open banking with a message that in the UK, open banking has already established itself as the primary way for building applications powered by user banking data. Now, for making payments online, although the traditional methods are obviously well established, we are seeing quite literal exponential growth, at least at TrueLayer, what we can observe, thanks to the reasons discussed above. Now, interestingly, the type of application and services that are powered by open banking are pretty vast. So from what I showed you, any application that accepts payments can use open banking. The lending industry uses open banking in doing affordability checks and credit assessment. Personal finance managers like Plum, and I would guess like Clio, also use open banking. Wealth tech, free trade or trading 212, and prop tech companies are very interested in open banking as a means to establish kind of credit worthiness. For example, people trying to rent or buy a home. So yeah, so here are some stats from the open banking page that show how much the ecosystem has grown. Cool. So this wraps up the brief intro to open banking, and I'd like to move on to the second bit of the talk, which is TrueLayer and data science. Sorry. But before I dive into the data science part, I'd like to present TrueLayer, what we do in the context of open banking. So we're a fintech B2B company. We're headquartered in Clerkenwell in London, and we enable companies globally to integrate finance into their applications. Our clients include some quite familiar names, and as I've mentioned, we've grown from around 20 at the end of 2018 to more than 200 today. And I guess that qualifies as hypergrowth, which is apparently is a word. Didn't know that. So we're looking to build the world's most valuable open banking network. We're already the biggest provider of open banking APIs in the UK. So we see 50% of all open banking traffic through our systems. And we serve hundreds of applications and millions of users. And we don't do screen scraping. What is quite interesting for me as a data scientist here is, you may have heard, like last week we announced we raised our Series D. We raised a substantial amount for our Series D, and the lead investor is Addition, who many of you will be familiar with Hugging Face and OctoML. So it turns out Addition is lead investor in those companies, and I'm pretty happy to be part of this group now. So it's pretty exciting, I guess, for data science at TrueLayer. Now, data science specifically. At the moment, we have data science-enabled services in production to support our products mainly in the data space. We're not yet in payments with data science. Now, such services include enrichment of raw banking data, which relies on machine learning and which I will cover in more depth in the next section. But we also use data science in our value-add products like identity verification. So identity verification streamlines onboarding of customers onto application and services by using identity data available from open banking. And the data science bit comes in matching the information a customer has provided during their onboarding with the data coming back from open banking. So that's one place we also use data science. Another one is kind of our Affordability Insights line of products, which is useful for companies who want to do credit assessments. So either giving out a loan or extending some type of credit. So our affordability product provides an estimate of kind of disposable income, which is the money that remains after regular inflows and outflows are taken into account. So such a service, as you can imagine, relies on advanced categorization of transactions, like understanding if a transaction is, it could be, going out and buying, movie kind of ticket, or it could be, paying for electricity. So we need to be able to distinguish these things. And it also relies on time series analysis. So some data science going on there too. And we have more products coming up, thankfully. Cool. However, as you may have deduced, like TrueLayer isn't a company whose initial product proposition was of data and payments APIs, basically. It, was based on data science. So we didn't set out, we didn't have data science in our mind as a company when we started, right? As a provider of APIs. And I guess there's certainly some companies where data science is really baked into the proposition from the start, like B2C companies like Pinterest, I don't know, Deliveroo. Data science is really baked into those services and products. But I believe for the majority of new companies, like data science is not a day one concern necessarily, and it usually comes a bit later to enable the creation of value add services and products and features, but after the main thing is established and validated. And I guess that was certainly the case when I joined TrueLayer back in 2018, where we had very little stuff going on with regards to data science. And TrueLayer is a very engineering-focused organization as a provider of APIs, right? So trying to introduce data science into the mix, into an organization that does engineering organization that has its way of doing things, it presents a number of challenges, right? And so as a first data scientist, these are things one has to encounter and kind of work with. And even decisions that may seem like no-brainer to us data scientists, no-brainers, for data scientists like us is, use Python, right? These things actually need to be considered within holistically, what is the burden that this creates to the engineering organization in terms of maintenance, in terms of on-call, in terms of whatever. So for example, TrueLayer at the time, all production services were in .NET. Now we have some Rust ones too, actually. But at the time, we didn't have Rust either. So to introduce Python into the mix, into production, yeah, that was not necessarily a trivial decision. But thankfully, it was an easy battle to win because of what Python brings for data science. And as you can see in this chart, like the number of services we maintain that are data science related has been growing since. It's interesting for me to see this chart because what this chart hides is, the messy nature of startups where many projects are a bit of, start, stop, and the ride is generally bumpy. But it's good to see at a high level, we're growing and the outlook looks positive too. Cool. So on to the third portion and main, I guess, topic of my talk. Excuse me. So let's dive into the first data science problem we tackled at TrueLayer. And this eventually became our first machine learning enabled service in production. And in this section, I won't focus extensively on the algorithms and whatnot, but I will cover at a high level the end-to-end approach of delivering this first of its kind service for the company. Okay, so the problem is enrichment of financial transactions retrieved from the banks. What does that mean? So here I have an example, kind of a coarse example of a financial transaction that, you can see the description, see the amount, timestamp. Of course, open banking mandates more fields, but for the purposes of this kind of demonstration suffices. However, like, this is pretty much, as clever as it gets, what you get back from open banking. You don't know, you don't get information of who the merchant actually is, or more insights into the nature of the transaction. You just get this raw data, right? And that's not necessarily something you can use and to build stuff upon. Like, I'm sure many of you will have seen, the old paper bank statements that have all these kind of ugly transaction descriptions, and you're wondering what on earth is this? They can be rather cryptic and unintelligible, and you can't even figure out who the merchant is in some cases. So at TrueLayer, with our data API, we want to add some extra context on the transaction in order to help our clients build stuff on top of the data. So what we try to do is try to add the name of the merchant that is associated with the transaction. In this case, I've picked a pretty random transaction here, which turns out is a little shop in Nuneaton, where incidentally my family lives. But and also we return the category of the transaction. So in this case, I guess it would be shopping groceries, and this is a proprietary taxonomy that we maintain. So again, in summary, we enrich the raw transaction with a merchant name and the transaction category based on our taxonomy. Cool. Now, as I mentioned, the description itself is cryptic and unintelligible in the first place, but imagine that it actually changes depending on which bank the transaction has been made at, so the same merchant, you can get an entirely different representation depending on whether you use Starling or NatWest or Monzo. And for a company like us who who processes data from all banks, basically, this kind of cardinality of possible representations presents a problem when you try to build stuff. If that makes sense. So I myself joined the company in late 2018, and the mandate was, we want a new merchant identification and transaction classification system. And the requirements are, it needs to have high coverage. So with coverage, I mean, let's say out of 1,000 transactions that flow through our systems, we're able to categorize a pretty high proportion of them. So in terms of percentage, and also high accuracy. So that's, so they have to be correct. Now that definition of correct is very fuzzy, as can be imagined. But secondarily, very importantly, TrueLayer is a company with global ambitions. At the time, we just operated in the UK, but we had plans to expand to the rest of Europe. So the mandate was to build something that can be taken and then essentially work if we start providing data API services in Germany or in Spain or in Italy. So this was the original mandate. And what I didn't mention, and what might be implied, is that there was already a solution in place for doing that enrichment, which was built by our software engineers, when full in startup mode. And a solution was built to address this problem that relied on what I think is a very practical and kind of very engineering way of solving problems. So it relied on two steps. So as I showed you the transaction description, it's ugly, whatever, but there's some tokens in this string, this messy string, that contain very useful information about who the merchant is. So our engineering team figured out how going to extract this. So again, this varies across banks and merchants, what have you, but regular expressions provide a way to strip this information out, essentially denoise the transaction and kind of reduce the cardinality of possible representations of that merchant as it enters our systems. So that was the first step, build a bunch of regular expressions. And the second step is once those tokens are extracted, do a lookup on a database where the key is the tokens, and the values are the name, the merchant name, and the transaction category. So very, very simple idea, but also very, very powerful, I think. And I guess, where did that database come from? Like, it came from, at the time, it came from a small workforce of kind of contractors, a few contractors who helped us build this proto database up. Okay, so the implementation, the way this looked like, it was a single .NET, a C# service, essentially a regex, factory, engine, machine, whatever you want to call it, that expected the transaction, parsed out the merchant tokens, did a quick kind of lookup on an in-memory database, a Redis instance, and either returned or didn't return the merchant name and categories. So on the plus side, like, this is a plus. This is low tech. Like, low tech is good if you're a startup. Like, so that's great. And also on the plus side, I was very surprised to see that it kind of works okay. So when I say okay, I mean it did hit quite a sizable, after we measured it, it turned out it did get quite a few of the merchants, like around 70%. And actually, this is true because if you think of where we spend our money, it's actually few merchants who are responsible for the bulk of the transactions. And this system capitalized on that, which is a very 80-20 way of thinking about things. And I like that. However, there are diminishing returns. So you can't go beyond, you've plateaued at 70% because there's a long tail of merchants. And let's say you go and build regexes, do annotation, like you put in lots of effort, but the returns are diminishing. The accuracy of the system was mediocre, to be honest. Hard to maintain. So imagine one day you wake up and you're not able to return Amazon. You're not able to identify Amazon. So like, okay, something's gone wrong. And you go into, okay, what's gone wrong? Is it the regexes? Let's go into the regexes. And you have a bunch of regexes and you have to figure out which one is responsible. Also, banks change their representations of the transactions. So this is a non-maintainable, like easily maintainable system. It doesn't improve over time, so it's done. There's no like feedback mechanism. There's no way for this to improve by itself. And it doesn't generalize to new geographies, because if we were to build this out in Germany, like someone would have to go and write regexes for all the German banks, and that's not what I signed up for, to be honest. So so we sat down and we sketched out the principles for the new system we were going to build, because clearly the previous one wasn't going to cut it. So bank agnostic, so we didn't want to rely on the transaction description format anymore. We just didn't want to care about it. Too much pain. Second principle, aim for no ops. Essentially, this is fancy words for minimizing the amount of intervention we would need to do when either bootstrapping a new geography or improving the whole process, the enrichment in a current kind of supported geography. And thirdly, we wanted to lay the foundations for continuous improvement towards automation, basically. And we realized that the cornerstone, this is moving from a rules-based system to eventually a fully data-driven system. And the cornerstone to be able to succeed in a fully data-driven system is quality data to train on, basically. And for us to get quality data, we really needed a a partnership with kind of a vendor who would be able to give us quality annotations back, and also we'd be able to spin up kind of annotation jobs programmatically and retrieve results programmatically. So this was the cornerstone of the overall strategy, I would say. And let's discuss now the data science solution we imagined. It's not like rocket surgery as rocket science, whatever. And we didn't want to rock the boat too much. But this is what we eventually ended up with. So using the transaction object that we saw before, we said, like, we can't do anything more, so let's try and identify the merchant tokens a bit more efficiently, a bit more easily. And the data science technique that can do that for us is named entity recognition. So we thought that, you know, training a named entity recognition model, like on this kind of short form data, would provide a way to get rid of regular expressions. And, you know, named entity recognition was very appealing because there are a bunch of Python projects that support it. There are a bunch of pre-trained models that can, you know, what is named entity recognition? It's a way to locate, to identify and kind of classify tokens in unstructured text, right? So this can be organizations, can be names, can be places. So there are lots of pre-trained models that can do that. And although we wouldn't find one exactly for our use case, we could certainly fine-tune named entity recognition for what we wanted to do. Cool. Then we didn't want to, again, like the lookup is not a bad idea. So we like the idea of this because of keeping a merchant database, but actually doing it more formally. Because the merchant database, if you think about it, is a source of IP that you can build upon as time goes on, right? So in the beginning, it's just a lookup between tokens, merchant names, and categories. But over time, it can become a source of metadata relating to the merchants. So we like this idea. But then, like, if we're talking about the system in production, like, okay, if the lookup happens, does it actually find, is there a match on the key, on the merchant name? So if no, then too bad, we can't identify the merchant, but we imagined that we could predict the actual transaction category by training a classification model. So as a fallback, if you will. Of course, if the merchant name is present in the database, great, we return it. And then we ask the question, is the category in the database? If yes, amazing, we return it. If not, fallback classifier. So this is the kind of end-to-end data science solution we envisaged, which relies on two machine learning models, one named entity recognition model and one, well, initially flat classifier. You know, we started out with one classifier predicting category and subcategory. You know, further optimization is definitely possible. So with this workflow, we envisaged we'd be able to, with good quality training data, we can take this, works in the UK, but we can get training data for Germany, keep more or less the same workflow, and it works too. So, yeah, so like this is the idea, but how do you give it flesh and bones, right? How do you make it, you know, how do you put it in production? How do you make it return value? So our plan of action in the early days was like, and these things, like the top bit, like is our early days, like set up observability, experiment to establish feasibility, and get to production as soon as possible. These things kind of happen simultaneously, so not sequentially. And at a later stage, we wanted to figure out, you know, properly the data annotation solution and MLOps, which is a pretty big concern for us. But in the early days, let's focus on the early days first. So setting up observability. So if you can't measure, you can't improve, right? And I guess the system we inherited at the time wasn't measurable. We didn't have data pipelines in place that could tell us what is our coverage for transactions, across different countries. Okay, it was one country at the time, but across different clients, across different banks, across different transaction types. Didn't have any of that. But that was crucial. So we began setting that up, and we decided let's build it out ourselves. So we created our databases, our Postgres databases, our data pipelines in Python, status pages, using Altair as the visualization. And then we realized after we built all of this that that's kind of inefficient, and our existing AWS stack provides all the tools we need. So, ingesting the data with Kinesis Firehose into use ETL. We do ETL jobs with Glue, which puts data in S3 in Parquet format, readable with AWS Athena with a SQL interface, and also dashboards with QuickSight. So a lesson here: think before you build. Well, sorry, it's tongue in cheek, but this was a bit of a mistake we did in the early days. Secondly, technical feasibility. Now, this should happen as soon as possible too. In terms of named entity recognition, we played a bit around, and Spacey has an amazing API, pre-trained models, massive community, a bit of a no-brainer, to be honest. And scikit-learn is even more of a no-brainer because there's no point when you're building out a system to go more complex than you must. So one point I'd like to make here is this has to be time boxed. So as data scientists, I think we have the tendency to experiment a bit. We bias towards experimentation, right? And we're never satisfied. We're never happy. But when you have to deliver, when you have to ship, you really have to time box this activity. And this is something we did well. So we established technical feasibility quickly. So we said, okay, it kind of works. And we moved on. The tricky bit is to make sure you've not kind of leaked, you don't have any data leakage and you're overfitting, what have you. But if you're sure of that and it kind of works, continue, proceed. Don't get stuck in doing experiments. That was another interesting takeaway. And deployment as soon as possible. I think this is one of the core things I personally learned at TrueLayer. I watched a talk by Andrew Ng also recently, and Andrew Ng emphasized that deploying to production, you're 50% of the way once you've deployed into production. There's so many, there are unknown unknowns, I guess, and you can sit around thinking about them, or you can actually, deploy and start getting feedback immediately. So that was another lesson for me, to have a more engineering kind of minded way of of doing data science. So deploying this as soon as possible for us meant we deploy this in production as a shadow kind of deployment, to be able to compare between our live system and our prototype. And in that way, we'll be able to measure with our observability where we have to improve and identify areas to basically double down on. So we built the deployment was, we found Fast API is a phenomenal web framework in Python that relies on type hints. Our Python, we always use type hints, and MyPy for kind of static type checking. A TrueLayer, and used GUnicorn as the parallelization kind of to manage Fast API for production purposes. So this we're very favorably, we look upon very favorably of this pattern. So the takeaway of this is maximize the rate of learning. Deploy as soon as possible in order to get more feedback. Don't wait. Now on to data annotation, which was something that happened further down the line. As I mentioned, we wanted to eventually fully automate our service. And the job types we envisaged were bootstrapping, let's say, Germany. And So that was going to be a big job naturally, right? But then you'd have the ongoing improvement jobs, smaller, and then accuracy monitoring, because as I mentioned, with our observability systems, we were able to measure the coverage, but we don't know anything about the accuracy. We can only infer it through the things people typically use, which is, distribution of predictions and what have you, but it doesn't really tell you the truth. So we wanted to have accuracy monitoring jobs in place where we have a sample of our predictions, send them over for validation, and get at least some confidence, some uncertainty interval around our actual accuracy. So for us to be able to do these things the way we wanted, we had a big checklist of a big checklist for identifying vendors that we could work with. I won't go through these 10 points, but like very clearly they had to be specializing in NLP, which is not the easiest thing. Like there are many companies that do visual and annotation for visual tasks. For NLP, it's a little bit more tricky, I would say. Obviously, global coverage, fully managed workforce. We didn't want to have to manage, the workforce ourselves. A front end system for annotations, and most importantly, obviously API enabled. So be able to create a job using APIs and retrieve the result using APIs. But most importantly, like quality SLAs. So being able to sign an SLA with a vendor that says that guarantees a certain accuracy beyond a certain point. And that was a cornerstone again of our strategy. Now, this took a while. This process took a while. And we wanted to move quick. But that was another lesson, like, vendor selection and, actually signing and getting your work, getting, the work started is a long process, and you need to budget for that. So we were a bit over ambitious, I would say, with our expectations there. And finally, the topic I wanted to cover to wrap up this section was MLOps. So MLOps, so before joining TrueLayer, MLOps was not on my mind. It wasn't quite clear what it meant. To be honest, it still isn't. But we sat down and we said, okay, what is MLOps for us? It's basically all the stuff that we need in order to be able to prototype, deploy, and maintain machine learning or data science enabled services. That's quite broad, and there are other people who have different definitions, and that's fine. But we broke it down. So we broke it down into, number one, we needed an environment for experimentation and collaboration, like local Jupyter notebooks, Untitled 0, etc. Yeah, not great. We needed experiment tracking, absolutely, both for the prototyping stage and for actual version control. Reproducibility is something we initially thought we needed very much as a financial services, company operating in financial services. What if one of our decisions is challenged? We need to be able to go back in history and say, this is the exact code of the exact model artifacts that produce this outcome. Continuous integration, continuous deployment, continuous training, we had kind of figured out because we used Circle CI in our engineering organization. But there were some issues with training, but anyway. And deployments we had definitely figured out because there was no way like our engineering organization would deviate from the established patterns we had already been going with for a while, in order to use something else. That would introduce too much complexity at the time our company was not able to handle. So it was fine. So we had the GitOps kind of Kubernetes on AWS was our environment, and use a standard kind of GitOps flow to deploy services on Kubernetes, and that was solved for us. And monitoring, Prometheus and Grafana stack was what we could use. So like we had a few problems. We didn't have all the problems that people trying to put data science into production have. So that was good. But like even at this stage, you know, as a data scientist, whatever, you have dilemmas, right? You know, on one hand, you know, on the one hand, you have your engineering organization saying, you know, you're good, just do it, you know, just, it's fine, you know, you can. They don't necessarily appreciate the concerns that we have as data scientists, so we can, you know, just do it, right? With the tools we have, we just, you know, build it. But then on the other hand, you know, you go on Twitter, you go on LinkedIn, you look at your email inbox, and you have all these amazing, like, hypey companies, hypey projects around presenting amazing things. And you're like, okay, like I have a bit of a dilemma here. What do I do? In the end, like we did fall for the latter. I won't say fall, but we chose essentially to partner with a company for that essentially covered the whole spectrum, but whom we used only for a limited number of capabilities. Like we didn't need to use Dot Science, the company we chose for deployments or monitoring, although they did offer that. So we chose to integrate with Dot Science, a process that took quite some time, but the platform was really cool, really interesting, and definitely a very promising project, but which did take some time to integrate with, and our DevOps team very grateful for further help. They weren't so happy when, or no one was really happy actually, when the very sad news came that Dot Science had to shut down during the pandemic, um, which was a sad development, as I mentioned, for everyone involved. Um, and we realized, sorry, I jumped too quick. So we realized we may have done a bit of a premature optimization here. Maybe we committed a bit too soon. And because in the end, like when after Dot Science, after we stopped working with Dot Science, you know, we realized we could have used Jupyter Hub on an EC2 instance for the experimentation environment. We could have used MLflow on an EC2 instance for experiment tracking. And reproducibility, we already could address with our existing stack. And the other stuff we already covered. So the takeaway was avoid premature optimizations. I spoke about this more extensively at a different meetup, but MLOps is a really interesting space, but premature optimizations are always a danger. So I'm going to wrap up the talk. Data enrichment today at TrueLayer. We cover 4 geos. We cover the UK, France, Ireland, and I believe Germany. And moving on to more, we process more than 10 million requests to our service a day. We've measured our coverage at around 75% and our accuracy at 85%. And I guess this is the current state, and really looking forward to expanding our data science services to more geos and more interesting capabilities. So a recap, what I talked to you about today. I talked to you about open banking, talked to you about TrueLayer and how we use data science at an engineering-focused startup. And I presented the case study around banking data enrichment, where I covered the things that were on our mind when we were first starting out and where we ended up today. As I mentioned, we're very excited about data science at TrueLayer moving forward. We have a very ambitious product roadmap, and I feel we're at and hope we're at an inflection point with regards to data science. So I'll wrap up the presentation by saying we're hiring. So you can check out our company page. Actually, I checked. I was going to provide a screenshot of the roles we're hiring for, but I was shocked to see that, yeah, they wouldn't fit on a single slide. And this is actually really surprising for me, because I remember when we were much smaller. So go check it out, multiple roles, and soon there will be more data science focused ones coming up. So I guess, yeah, that's the end of the talk, and thanks for hanging around and hearing me out.
Perfect. Thanks very much, Alex. Absolutely fantastic. Really enjoyed hearing you present there, and you covered a number of areas, and it was nice to get that sort of introduction to open banking at the start as well, which kind of really set the scene for everyone, I think. So absolutely spot on. We've got a few questions that have come in, so we'll definitely keep you here a little longer and run through some of those, if that's okay.
Sorry for overrunning, by the way, I just realized.
Mate, no problem at all. We like this sort of stuff. As long as the content's good, we're happy. There's a few people in the chat actually just pinging across a little message there. Andrew Logan, Phil Sanderson, Michael Bateman, all saying very good. Thank you. So yeah, if you've enjoyed the talk, please do pop a little message in the chat. It's nice for the speakers to see that. In terms of the question at the top there, if you're reading along, Alex, is from Joanna. You described that by joining TrueLayer, you had to learn how to fully deploy models with CI/CD, et cetera, a number of technologies. I'm on a similar journey where I've now become a nearly lone data scientist who is expected to do all of this, but do not have a software engineering background. Have you got any advice?
I can absolutely sympathize. I guess one of the traps I wouldn't say traps, but I don't think data scientists were prepared like for like, we weren't prepared in online courses or what have you, that, you know, we join a company and there are all these things to worry about, you know, when I was starting out, and I guess up until this point, like most online courses are about, oh, this fancy new algorithm or this data set, and you go, you know, tune your models, what have you. I found that what was really like, so firstly, I believe I had a lot of support by the engineers in my company. I won't proclaim that I was able to learn this all by myself with my own powers. So I really had to rely on the expertise of colleagues and really put myself, you know, open up and be vulnerable. And that's fine. And I think like departing from the mindset of a data scientist, at least temporarily, is really important. And one way you can do that on your own time is to try and deploy a project, like work on a project on your own project, do it yourself. So maybe you can create a simple like machine learning model and deploy it on I don't know, AWS Elastic Beanstalk, on Heroku, and add all the little functionality you want to learn incrementally. That is one way, I guess.
Yeah, makes sense. And I love a little side project, man. I think you've got to have that in there to keep yourself current. So just as we're doing it, quick shout out for some of the comments coming in. John, Gabriel, Adi, Hamed, Michelle, Kaylee, Neil, loads and loads more. I can't get through all of them, just saying thank you. So just to reiterate there, Alex, thank you very much.
Thank you.
Just to flag actually as well, we do have Money Hub building on our open banking kind of talks next week as well. So if you enjoyed Alex, please do come along again next week. We'll go back to the questions. There's a question at the top there from Cav. Cav's asking, what are the open banking alternatives for PSD2 in other countries? How similar are they, and how difficult would it be to combine across multiple countries? And I guess just to add to that, if possible, just for anyone that doesn't know what PSD2 is, if you could give a bit of an overview of that as well, that'd be great.
Of course. Now, as like open banking is UK. It's not Europe. It's not the rest of the world. I think there's some open banking, like maybe in Australia, there's the term open banking, but when you hear open banking, it's UK. But open banking was created because of PSD2, which is a European Commission regulation. So this mandated the banks, essentially forced the banks to open up their systems with open APIs. Just to clarify, that doesn't mean if I want to go and see David's like bank data, I can just send an API request. No, there has to be consent, and that's very.
It's not worth looking at, Alex. It's not worth looking at. Don't worry.
Yeah, exactly. Okay, so we said open banking is the UK flavor of this. In the European Union, though, in Europe, there are other protocols. So there are things like XS2A. There are things like, which covers, I think. I'm not an expert, but it covers a few countries. And there's also STET, which is France. So countries have their own flavor of open banking across Europe. And eventually all European countries have to enforce it. So across the whole of Europe, there will be different flavors of open banking. Not completely the same, which is where, you know, if you're trying to implement APIs against the different protocols, it can get hairy. So you'd probably want to use a company like us or someone else to do that for you. And like in the US, I think the situation is still screen scraping. I believe the US is yet to be disrupted by such technologies. But as you can see now, once the incentives are proven for the financial institutions, which we're on the way to do, then it's more likely you'll see this open API first mentality becoming worldwide. But it will be a journey to get there. By the way, I'm not the expert talking about this, just saying.
You're our expert, Alex. This is good. This is good, and that was good for context actually, because I've definitely been learning along with everybody else. So, and I must admit, open banking. I mean, for me personally, it's been a really bit of a game changer in terms of accounting software and stuff like that. You know, we use QuickBooks as a business, and it's importing lots of transactions and classifying them and stuff like that. Which is so the more the better, as far as I'm concerned. The next question there is from Yading. Can you please briefly talk about other ML projects that you have in production, the ones with the biggest buy-in from the leadership team? So what have been the big wins for you at TrueLayer?
Well, I guess TrueLayer is a startup that reassesses. As a startup, you have to reassess your direction constantly. And as we grow, we have had many new people join the company with much more experience who are able, and as a company, we have to adapt to, as a startup, we have to adapt. We can't say, oh, we want to do this and we do it forever by closing our eyes. So there have been projects that have started and have not been continued. And that's absolutely natural and it's healthy, I believe. Peter Thiel, who is maybe a controversial character, but he has many interesting insights in his book about why it is vital to do this. So to answer the question specifically, at the moment, I would say the projects with the highest buy-in are identity. So being able to reconcile someone's identity during the onboarding process. That is one of the main ones. And additionally, like what I mentioned on affordability. So building out a way to essentially understand if someone can afford, based on their transactions, to receive a line of credit or get some service in a regulated environment. These are the two ones at the moment, but we're very bullish on our payment strategy. So I would expect payments and ML, people already will have some ideas. So I bet it will be pretty strong on that front too.
Perfect. Thank you. Thank you. I am a little conscious of time. We do normally try to keep this to an hour, but there's a few questions still coming in. And if you have 5 minutes, we still have a good number of people connected. So we'll try and do a quick fast round of get through some of these questions.
Sure.
Question, just quickly, actually, you mentioned Peter Thiel's book there. Do you happen to remember the name of that?
Yeah, it's like it's oh God. 0 to 1, I think, isn't it?
0 to 1.
Yeah.
Do you know what's embarrassing then in that case? I have that book on my bookshelf and I've not read it. I'm a bit of a fan of buying books, but not reading it. I didn't realise that was his.
Yeah.
Okay, question at the top there from Jagdish. Can you please, number one, give an example of the annotation you mentioned? And number two, what is the impact of poor accuracy of named entity recognition on your business model? Maybe in case of the speed of time, maybe we just focus on number two rather than delving into specific examples of annotation. So what is the impact of poor accuracy of the named entity recognition on your business model?
Oh, this is a fantastic question. And that is, I think, a very central question that informs an entire data science strategy. So for the example I shared specifically, nothing will happen. It will be uncomfortable, but it's not a service that needs to be accurate to a second kind of decimal point, right? So, okay, the impact is that our customers who are building insights off the back of our predictions, those services will be degraded. However, if we're talking about critical services like credit assessments, what have you, our input is only one out of many. And the companies themselves kind of make sure that, take on the risk of that decision. So in either case, like from our point of view, And from our client's point of view, it has to work. So it's not like one of those things you can absolutely quantify, but it kind of has to work, and that is different for each of our clients. It's a tricky one, but ultimately, it's not like something that should, like the second decimal point means thousands of dollars. It's not like that. So we can afford to be a little bit more relaxed with some things, but it's not the same case with all companies. Absolutely.
Perfect. Perfect. Thank you. You were correct in the book there as well, and Nora's helpfully put a link into the answered questions. So if anyone wants to check that out, that is there. We'll go to the question there from Mital at the top. I guess this is defined by standards, but how do you maintain the security of the bank's customer data? Do you use encryption?
So what I really need to stress here that we're just pipes, right? We don't store any data. Like we're pipes that enable the flow of data. Now I said something that many will likely pick up on. We do store some data, but those things that we store are only anonymous, like merchant-related transactions without account identifiers. So it's like a soup of, there's no customer information, no customer context, and this allows us to build out the kind of merchant identification and categorization I talked about. But otherwise, we don't store any customer data. So that's a problem we don't, at the moment, have. Of course, there's always a challenge. If you want to build something more, you need data. But for us to be able to do that, we need a really principled kind of framework and a real incentive for our customers and to their customers to have data stored with us. This is something we might consider in the future.
Okay.
And yeah, in terms of the pipes themselves, they are protected by the protocol of open banking, which is extremely secure authentication model. So yeah, definitely loads of resources for that.
Thank you very much. And again, I'll just, sanity check with you, but in terms of the question there at the bottom from Michelle Norton, will open banking APIs be able to maintain the well, I can't even say the word, anonymity that blockchain demands? Is that relevant, basically?
It could be relevant, but I don't feel it could be relevant. I don't know. That's an interesting question. Like at the moment, like it's not something we dabble
Had
with.
to think about. Yeah.
But if we consider our payments API, I don't know. Like it's interesting, actually.
Yeah.
I don't know.
Further conversation. This is the difference with not having a live meetup. We'd be talking about this over a beer and pizza, wouldn't we, afterwards? But sadly not today. I think we've run over. I'm going to take one more question, and then we'll let everyone get going from there. So I'll go to the question from Gabriel. It starts off by saying brilliant talk, which is always nice to see in a question. I have a couple of questions about the 15 to 20% of transactions that are not classified correctly. I was wondering if you could expand on this. Is this because of the merchants in that they're very small, they're not enough transactions? Is the 15 to 20% weight the same if one looks at the transaction amounts, e.g. are they all small transactions?
So the latter question, yeah, I wasn't referring to the amounts exactly. It would be interesting to see like how off we are in terms of amounts. That would be an interesting metric to look into. I guess in terms of when it gets wrong, it gets wrong when if named entity recognition kind of identifies tokens that are the wrong tokens, then the DB lookup might match the wrong entry. So this is where the failure is likely to happen. Otherwise, if a DB lookup doesn't succeed, then it's not categorized. So that is the coverage issue. But if it's wrong, then it's most likely because of the named entity recognition kind of identifying the wrong tokens, which happens.
Perfect. Thank you very much, Alex. We're going to start to wrap things up now, I guess. So I'm going to go back to some of these comments. I've got no chance of getting through all of them, but just to shout out a few: Hugh Westcott, Richard Crawley, Veronica Phillip, Chris Wellage, Thomas Oliver, Georgie, John Neary, loads and loads more, all saying how much they've enjoyed the session, enjoyed the presentation. Again, Rory just pinged one in there. So I'd like to very much reiterate that. Absolutely fantastic session, good fun, nice and interactive, and really appreciate your time, Alex. So I hope you've enjoyed being part of it. And yeah, yeah, we'll maybe even get the chance to do this later in the year, perhaps even do it live at some point and go from there. But thank you very much. I hope you've enjoyed yourself.
Absolutely. Thank you so much for attending and for the kind words, everyone. It was a pleasure.
Perfect. Thank you, everyone at home. We look forward to seeing you at an event in the future. But thanks very much, and we'll see you next week. Bye-bye.